Hi everyone. So this is going to be the next part of the physics self-study series. So today we're going to talk about some of the more advanced sort of undergraduate physics because last video we started laying the foundation by learning calculus and some introductory physics. So I think for this next part, the maths that we need to learn is what we should start with. So we've already done, most of the topics in a calculus book at this point: differentiation, integration techniques, maybe a little bit on ordinary differential equations. But at this point, I'd recommend that you start really going into differential equations, first order differential equations, second order differential equations. And at first, I think you can kind of just focus on um, ordinary differential equations. So you don't necessarily have to do partial differential equations quite yet. I'd also say learning some analysis is probably a good idea at this point. Learning about sequences and series, in particular, Taylor series are quite important. So at this point, that's what I'd recommend starting with. And you also need to learn some more linear algebra. Last time we kind of just talked about vectors, but now you really want to go into matrices a lot more. Um, so at this point, if you look at like the linear algebra book I recommended last time, you really should cover pretty much all the topics in a book like that. Specifically, you want to know about matrices, adding matrices, multiplying matrices, working out determinants. You want to know about reduced row echelon form and solving linear equations. You're going to want to know about eigenvalues and eigenvectors. Um, you're going to want to know about linear independence of vectors, vector spaces, inner product spaces, all of that good stuff. And in terms of physics at this point, I'd say you really need to go through the classical mechanics of waves, because that's going to become very important in the electromagnetism and the quantum mechanics that we're going to do next. So at this point, you also need to work on electromagnetism. Griffiths is the standard text, Griffiths' Introduction to Electrodynamics. And you're going to want to work through most of the beginner chapters in there, maybe the first 4 or 5 chapters. And especially you want to get to Maxwell's equations, which does also mean you need to know vector calculus. I forgot to mention that. So if you haven't in your calculus studies done vector calculus yet, learn a little bit of vector calculus before um, diving into Maxwell's equations. And Maxwell's equations are going to use the wave equations we learned previously. So yeah, get yourself Griffiths and just work through it. Um, then after that, I think we're ready to start with some new areas in physics that are actually quite different. So up next, I'd say get yourself a statistical mechanics book. Um, Thermal Physics by Schroeder is a common one. Actually, David Tong's lecture notes are really good. He's a physicist from the University of Cambridge, and his lecture notes helped me a lot as a student. So those could also be helpful for statistical physics. And at this point, we're also going to want to start with quantum physics. And this is part of the reason to learn more linear algebra and differential equations, is because you're going to use that a lot in quantum mechanics. So yeah, Thermal Physics by Schroeder is a good book. I think Landau and Lifshitz is a little bit older, and you could use the David Tong statistical physics notes. In terms of quantum, I think starting out with quantum, you're going to want to just stick to Griffith's Intro to Quantum. Yeah, that's a perfect introductory textbook, basically. And around the time you're starting quantum, I think you're going to want to learn some Fourier analysis too, because that does come up in Griffiths. So have a look at Fourier analysis and partial differential equations at this point. Now, this next part is a little bit, well, we've sort of reached the point where you know most of the foundational physics. Once you've learned quantum and statistical physics to some degree, and classical mechanics and electromagnetism, you've learned most of the foundational physics that's really required. So at this point, I think most university curriculums will start to diverge a little bit, going into different areas, depending on the university and so on. But typically, you'll do something on modern physics, which might be nuclear and atomic physics. Astrophysics might play a bigger role at this point. Computational physics could play a role. So I would say have a look at your introductory textbook that you did previously, your sort of first physics textbook. Look at the chapters that interested you. Are you interested in nuclear physics? Are you interested in cosmology? Are you interested in atomic physics? Are you interested in optics? And maybe get yourself a book on one of those topics. Nuclear physics is a topic that interests me quite a lot, so I can recommend you the book by Crane. And there are loads of other nuclear physics textbooks. So yeah, I might talk about those at some point in the future. But yeah, I think you can start to sort of go in different directions. At this point, you've covered, once you do that and you learn a couple of other topics, you've pretty much covered all the essential stuff from an undergraduate degree, I would argue. If you want to go on and do graduate work, you might need more advanced textbooks. So, like for classical mechanics, you can use Goldstein's textbook. For quantum, you can use Sakurai. It's a pretty common book. That's Sakurai. For statistical physics, I think the book by Parthia and Beal is pretty good. And for electromagnetism, Jackson is the standard sort of set text. So, if those are like the foundational areas, and you can start building up other stuff onto it. You can start looking at astrophysics, cosmology, general relativity. In terms of maths, there are sort of different things you might want to learn. Complex analysis could be kind of important, depending on where you want to go. And I think tensors are going to be very important too. So those are kind of the new areas you can go to. So apart from that, I think the next video is going to be about starting to actually work on a self-study plan and building the discipline to do this, because, well, I'll talk about this more in the next video, but this is really a long-term plan. If you think about how long does it take you to get an undergraduate degree, depending on your country, it might be 3 or 4 years. So that's quite significant. So if you're studying this on your own and you're not doing it as a full-time job, as a student, then it's probably going to take you longer than that. Even though arguably studying on your own is more time efficient than studying as a university student. So that's also a reality, is that this is a big commitment. You don't necessarily have to do all of this. You could stop at a certain level once you're happy. But if you're going to follow this whole program, it is a big time commitment. So I'm going to talk more about that in the next video. Okay, thank you for watching.